Hello everyone. Today I am going to talk about particle settling in glycerin. Let's examine a classic fluid mechanics problem involving particle settling. We have a glass beads with a diameter of 3 millimeters that settles through a glycerin at constant velocity of 1.5 meters per second. Our task is to calculate the viscous drag force acting on these beads. The key assumption here is that Stokes flow condition apply, which means we are dealing with very low Reynolds number flow where viscous force dominate over inertial force. We are given three important parameters. The dynamic viscosity of glycerin is 1.5 Pascal seconds. The bead's diameter is 3 millimeters and the settling velocity is 1.5 meter per second. For this problem, we will use Stokes' law, which describes the drag force on a sphere moving through a viscous fluid at a low Reynolds number. The formula for the Stokes drag force is Fd equals 6 pi mu r into V. Let me explain each variable. So mu represents the dynamic viscosity of the fluid. In our case, glycerin. R is the radius of the sphere, that is here 3 millimeter diameter is given, means half of the diameter, and V is the relative velocity between the sphere and the fluid. Now here an important notes, this formula is only valid for Reynolds number less than 1, which defines the creeping flow regime where viscous effect completely dominate. Now let's substitute our values into the equation. First we need to convert units properly. The radius equals 1.5 millimeters, which converts to 0.0015 meters. Our viscosity mu is already in the correct units at 1.5 Pascal seconds, and our velocity v is 1.5 meters per second. Now putting all these value into Stokes equation, that Fd equals 6 times pi times 1.5 times 0.0015 times 1.5. So that will give 6 times 3.14159 times 1.5 times 0.0015 times 1.5, and if we do the calculation we'll get Fd is nothing but 0.0636 Newton. Therefore, the viscous drag force acting on this glass bead as it settles through the glycerin is 0.0636 Newton. This relatively small force demonstrates how viscous drag in highly viscous fluid like glycerin can balance the gravitational force on small particle that results in constant terminal velocity. That's it. Thank you.